Hello everyone. Can you hear me? Hello, can you hear me?
Yeah, Ram, I can hear you.
Okay. So in this session, we'll be discussing week 9 to 12. Okay. Week 9 I'll be handling, and the remaining weeks Vishal will be taking care. Okay. So let me share my screen. So what I will do is I'll look at we'll discuss the revision slides, okay, which would have been already shared with you. Okay. After that, if you have any questions in week 9, we can discuss those. Okay. But first we'll briefly summarize the week 9 contents. Okay. Is the screen visible? Hello. Can some of you confirm that my screen is visible?
Yes, sir.
Yes.
Okay. Okay. So first thing is that so in the previous week, like in the week 8, we would have known about this convex functions, and now we are just discussing about this properties of the convex function. Okay. So for the convex function, for the global minimum to be existing, right, at a particular point x star, that particular x star at that particular x star, the gradient should be equal to 0. Right? This gradient is for this higher dimension, but if it is just a single dimension, then we just say that f dash of x equals 0. Okay. So that's what we have, because only when we have that only, you can have this f of y is greater than or equal to f of x star, right? So this y minus x can be positive. So this whole term only when we have this del f of x to be like equal to 0, then only we can say that x star is the global minimum. Okay. Okay, so the revision slides would have been already shared with you. Vishal, are the revision slides shared? Okay, yeah, maybe after this live session, we'll be sharing this with you. Okay. So the first property of convex function is, let's say, like if you have two convex functions, f of x and g of x, then the addition of those two functions, f of x plus g of x, is also going to be convex function. Okay. The proof for it is simple. Like we have this we have this property of convex function, which is f of lambda x plus 1 minus lambda into y. It's going to be less than or equals to lambda into f of x plus 1 minus lambda into f of y. Okay. So similarly for g of x, I mean for g of lambda x plus 1 minus lambda into y, we can write it the same way. So since this is less than or equal to this one and this is less than or equal to this one, the addition of this will be less than or equal to this value. Okay, which basically means we can rewrite this and form it as like lambda into f of x plus g of x, which is nothing but h of x. I mean, we assume that h of x equals to f of x plus g of x. Okay, and we can write as the other one as 1 minus lambda into f of y plus g of y, which basically gave us this form. Okay, lambda into h of x plus 1 minus lambda into h of y. So basically, h of lambda x plus 1 minus lambda into y is less than or equals to lambda into h of x plus 1 minus lambda into h of y. So since this condition is satisfied, we can say that h of x is a convex function. Okay. Yeah, the PDF will be shared. Okay. The other one is when we have this when we have f as a convex function, and then when f is a convex and non-decreasing function and g is a convex function, then f of g of x is going to be a convex function. Okay. The proof for it is also similar. Okay. When you have f of g of x, we have lambda x plus 1 minus lambda into y. G of lambda x plus 1 minus lambda into y, it's going to be less than or equals to lambda into g of x plus 1 minus lambda into g of y, right? Since we know that f of x is non-decreasing, which basically means f of lambda into g of x plus 1 minus lambda into g of y, right? This value, it's going to be less than or equals to lambda into f of g of x plus 1 minus lambda into f of g of y. Okay. Since we have used this non-decreasing like that point here. Okay. So which basically means that this value is nothing but lambda into h of x plus 1 minus lambda into h of y. So basically h of lambda x into 1 minus lambda y is less than or equals to lambda into h of x plus 1 minus lambda into h of y. Okay, so this is this convex criteria. Okay, so this is one of the 4 definitions, right, through which we have defined that a function can be convex. So yeah, so by this we can say that f of g of x is a convex function. And the other important one is when we have this f is a convex function and g is a linear function, then f of g of x is going to be convex. Okay, so we have this f of g of lambda x plus 1 minus lambda into y, which is exactly equals to lambda into g of x plus 1 minus lambda into g of y. Okay, because g is a linear function. Okay, that's how we can write this. Okay, otherwise we cannot write this. So this will be less than or equals to lambda into f of lambda of g of x plus 1 minus lambda into g of y. This is because f is a convex function. Okay, so from step 2 to step 3 we have written because f is a convex function. All right, so because of this we can say that when f is a convex function and g is a linear function, then f of g of x is going to be a convex function again.
Sir,
but yeah,
sir, what about g of f?
What about g of x? G of x is a linear function.
No. Miss, we are saying that the composition h is equal to f of g.
Yeah, f of g of x. Yeah.
And so, what about g of f?
G of f of x.
Will that be convex?
So when we have this g of f of x, so which basically means no, we cannot say whether that's a convex or not.
Okay.
Cannot say. Okay.
Okay, sir.
So the other one is in general when we have this f and g both are convex functions, we cannot say that f of g of x is always a convex function. Okay, so there could be a case where it is not a convex function also. So for example, you have this g of x is x square and f of x is e power minus x. F of g of x is e power minus x square, which is not a convex function. Okay, clear? Okay.
Sir, can you again explain how we can identify if f of g of x means convex or not?
Okay, so one direct way to identify whether f of g of x is convex, like let's say like any function. Okay, any function, one way to identify whether that is a convex function or not is to find out f double dash of x. Okay, is to find out f double dash of x, so that f double dash of x should be greater than 0 irrespective of what the value of x is. Okay,
Means it should be increasing function, right?
We cannot say that it's increasing, but yeah, like if double dash of x is increasing, yeah, it's positive. Okay, which basically means f dash of x is increasing. Okay, not f of x is increasing. Okay, all right.
But sir, in this case, f double dash of x, like e to the power minus x, if we take the derivative 2 times, then it will be positive, right?
E to power minus x, yes. E to power minus x, it will be positive. That's why we are saying that f of x is convex function. G of x is also convex function because f double dash of x square is going to equal to 2, which is a positive number. Okay, but the thing is, f of g of x e power minus x square, if you double differentiate it, it is not always going to be positive. Okay. Yeah, because of that.
Excuse me,
yeah.
sir. So this PDF would be shared, right?
Yeah. This PDF will be shared.
All right, sir.
Okay. So we can say that G is concave if and only if minus G is convex. Okay. Suppose let's say f is a convex function, then minus f is going to be a concave function. Okay. Clear?
Okay.
The concave function is opposite of this convex thing. All right.
Yes.
So when they ask you to find out whether a function is concave or not, so all you need to do is you can just do the opposite of that. Is like you can take that minus f of, like, let's say I gave you function f and I asked you to find whether it is concave or not. So you can check for minus f whether minus f is convex or not, and if minus f is convex, then we can say that f is a concave. Okay. All right. Okay.
And sir, for convex, the double dash you need to find, right?
Yeah, f double dash fx simple, and then you need to see that whether like within the domain, right, it should always be positive. Okay.
Yeah.
And if they did not mention the domain, that means that it's from minus infinity to infinity. From the minus infinity to infinity, that is over the entire span, right? Whether that is positive or not, you need to see. Okay.
Yeah, thank you.
So the application of this optimization problem in ML is linear regression, right? So what we assume is in the linear regression that that we'll get this y as is equals to w transpose into x, right? W transpose into x through that we'll assume that like that is we'll assume that function to be a linear function. So we'll assume y equals to w transpose into x, right? But we have the xi values, we have the yi values, but we need to find this weighted vector, the w transpose one. Okay, the w vector we need to be finding. So for finding it, what we do, we need to this w transpose xi. It's an output that was predicted by the linear regression or the linear equation which we have mentioned, right? So that is y equals to w1x1, w2x2, w3x3, and so on, like wn(xn). That is the linear equation which you assume, but the actual value, y value is something else, right? So the difference between the calculated or the output of this linear regression and the actual y value, we need to minimize that differences, right? So basically, that error should be minimized. So this you could see w transpose xi minus yi. Okay, it is a function of w. It is a function of w first of all, and then they similar to this x square one. They similar to x square one. So and we know that x square is a convex function, right? So we can say that this minimum of w, minimizing w, okay, of w transpose xi minus y whole square. That function is also a convex function. Okay, since it is a convex function, we can solve for this minimization one. Okay, using what we have learned previously. All right. So the one way to do this is if you find the gradient of it, gradient of this. So you can assume this f equals to this error function one, and then we need to minimize that error function. So we find the gradient of it. So gradient of f of w equals to x transpose xw minus x transpose y, right? So according to this what we have learned, so the minimization, the global minimum value will occur only at w, like when the gradient is equal to 0, right? So we can equate this gradient to be 0. Okay, we can equate this gradient to be 0. So if we equate this to 0, which gives us x transpose x w minus x transpose y equals 0, which gives w star, like we have mentioned it as w star just to denote that it is an optimal solution. Okay, which gives w transpose x equals to x transpose x inverse of x transpose y. But the problem with this is, as we have known, with the x transpose x, with the x transpose x, we need to find the inverse, and finding the inverse, it's going to take like a lot more time. Okay, lot more time complexity. So it's going to take for a computer a lot more time to compute. So this is ideally not a this is not an ideal way to get the solution for this W star. But getting W star through this is a the straightforward one, and we'll get the exact W star. Okay, but we will not be using this. So the one other way to do it is just like we did for this gradient descent method, right? What we do is we assume some W value initially, and then using iterative process, we will reach that optimal W star. Okay, is this clear until now? Okay. So the reason why we talked about this W transpose xi minus y whole square, right? Whether that is convex or not, because while solving for this gradient descent, we will solve for like we'll solve until del f of w is equal to 0, right? Because once we reach the del f of w equals 0, that means that we have we have arrived at the optimal solution, right? Only when f is a conic function, then only we can say that the local minima is also a global minima, right? We can say that GD will reach the global minima, okay? Even if we reach the local minima, so if it is a conic function, right? Okay, so instead of finding this w star directly, what we do is we just use del f of w. We just use the del f of w to find the optimal value. Okay, like each time we'll be finding this wt t plus 1, wt plus 2, and so on. Like after like n iterations, we'll be arriving at this optimal solution. This eta t is a step size which you have seen, which you already seen in the week 7. Okay, for the gradient descent. Okay, so the stochastic gradient descent method. So what happens is, here we have like here let's say like I have like 1000 data points. I have like 1000 data points, and computing that for 1000 data points or like 10,000 data points, that's like too much for us to solve for. That's too much for us to solve for. So what we do is we just take a sample of it. We won't be using the entire data. We just take a sample of it such that our computation will be even more faster. Okay, we have used this gradient descent so that it will be faster than this direct method, and still we are reducing it so that it will be even more faster. And actually we were shown that after some iterations, the stochastic gradient descent method and the actual gradient descent method both give us the same optimal solution. Okay, clear? Until now we are trying to solve for directly the this optimal solution, right, without a constraints. Okay, without constraints. But now if you have a constraint, how do you solve for this objective function, right? So we have this minimum of f of x subject to h of x is less than or equal to 0. Okay, only when h of x is less than or equal to 0, only within that domain we should try to solve. We should try to find the minimized value of f of x. Okay, until now, until here, we never looked at the gradient. We never looked at the constraints. That is, the domain for x is not limited, right? So the way for you to solve is, we have this Lagrangian function. So let's say like I have only one constraint, h of x is less than or equal to 0. What I'll do is I'll have x comma lambda. I have L f x comma lambda equals f of x plus lambda into h of x. So first what I do is I'll maximize the L of x comma lambda and then minimize the rate of. Okay. So when I maximize L of x comma lambda, right? I use the lambda value such that L of x comma lambda will be maximum. Okay. So when h of x is greater than 0, what I'll have is I'll have lambda equals to infinity, so that this entire L of x comma lambda will be infinity. Okay. So basically when h of x is greater than 0, L of x comma lambda is going to be infinity. But when h of x is less than or equal to 0, since I want to maximize it, I'll have lambda equals 0. Okay, I'll have lambda equals 0. So that L of x comma lambda is going to be equal to f of x. Okay, clear? So if you looked at it, and now when we're trying to minimize this max of lambda is greater than or equal to 0, L of x comma lambda, what we're trying to do is we are trying to minimize f of x only in the case of h of x less than or equal to 0, because the infinity case, right? The infinity case will not be considered because we are looking at the minimum, not the maximum. Okay, this is clear until now?
Excuse me, sir.
Yeah.
Sir, up to the this was okay, but that max and min combination is little bit confusing. I'm not able to understand.
This max and min combination?
Yes, sir.
This one?
Yes, sir.
Okay. So L of x comma lambda is clear, right? Lagrangian function is clear.
Yes, sir. It is a week up to the week 8. Means we
Okay,
studied
okay.
up to the Kkt.
Okay. So after this, let's say like I have LFX comma lambda, right? Let us look at what the value of x comma lambda, LFX comma lambda will be when h of x is less than or equal to 0. Okay. When h of x is less than or equal to 0. When h of x is less than or equal to 0, since lambda should be greater than 0, since lambda should be greater than 0, what we have is Lagrangian of x comma lambda will be equals to f of x plus lambda into h of x. It will be less than or equal to f of x, right?
Yes, sir.
Right? It will be less than or equal to f of x. Okay. But then what I want is I want to maximize the L of x comma lambda. I want to maximize f of x comma L of x comma lambda. So what I will do is I'll substitute lambda equals 0. I'll substitute lambda equals 0 such that the maximum value possible will be equal to f of x. It won't be less than f of x. Okay. Is this clear until now?
Yes, sir. But sir, why we want to maximize the Lagrangian function?
Yeah. I'll come to that in a bit. Okay. I'll come to that in a bit. So until now, what we have seen is when h of x is less than 0, when h of x is less than or equal to 0, we'll substitute lambda equals 0. Such that the maximum of L of x comma lambda, maximum of L of x comma lambda is equal to f of x. Okay, is equal to f of x. And then let us look at the other case of h of x is greater than 0. When h of x is greater than 0, since you want to maximize L of x comma lambda, I'll substitute lambda equals to infinity. So I'll have L of x comma lambda equals to f of x plus infinity, which will give me infinity. Okay. So we have like two cases here. First one is I have Lagrangian of x comma lambda equals to f of x when h of x is less than or equal to 0, right? And then I have L of x comma lambda equals to infinity when h of x is greater than 0. Until now is clear?
Yes, sir.
Okay. So now when I try to minimize this L of x comma lambda, now when I try to minimize L of x comma lambda, all the infinity case anyway I won't consider, right? Because I'm trying to minimize it, so I won't look for the infinity case, right?
Yes, sir.
So basically what I'm doing is I'm just trying to minimize f of x. So I'm just trying to minimize f of x over h of x less than or equal to 0, because the case of h of x is greater than 0 is gone away. That is an infinity case which is gone away. Okay. So what I'm trying to do is I'm just doing the same thing. I'm just doing the minimizing of f of x subject to h of x less than or equal to 0 and I'm doing. Okay.
Okay, sir.
Because Lagrangian of x comma lambda when h of x is less than or equal to 0 is going to be f of x only. So when I'm trying to minimize the maximum of this L of x comma lambda, what I'm basically trying to do is I'm just minimizing f of x subject to h of x less than or equal to 0. It is the same thing. Okay. Clear?
Yes, it means we have converted that above equation into the one equation.
Yeah, exactly.
By the Lagrangian function.
Right.
Yes,
Okay.
sir.
So that was that we are able to do by maximizing it first, and then like minimizing it later. Okay. Okay. This is
So why we want to maximize?
I want to maximize it.
Why?
Okay. The reason why we want to maximize it, we do not want to get the case of h of x greater than 0. We do not want the case of h of x greater than 0, right? Because our condition is h of x is less than or equal to 0, right? That is the reason. Okay.
Okay, sir.
Yeah. Okay. This primal and dual problem, it is just a shifting of this. Generally, what happens is first solving for this. To solve for this primal problem, I first need to solve for this max of L of x comma lambda, and later I need to minimize it, right? I can directly minimize the equation, okay, using a property of convex and the gradient itself, okay, but I do not know how to maximize the function directly, okay, like in the I can write it, I can solve it like directly, okay, but then using iterative process I do not know how to solve for it directly, okay. So that's why what we do is we do the dual problem, that is first we minimize over x. First we minimize over x, and then like later we maximize it with respect to lambda. Okay. Is this clear what I'm talking about? So this is called a dual problem. The shifting of this, the reason why we have done is now inside we will be doing minimizing of x, minimizing with respect to x of Lagrangian of x comma lambda. So this I can do directly. This I can do directly. So after this, the maximization can be done easily. Okay, that is the reason. So if they are not able to solve using primal directly, they go for this dual problem, and then after that they check whether the dual solution is actually equal to primal solution or not. Okay, the duality is a condition is we have this solution with respect to the primal one, right, which is f of x star. Okay, and then solution with respect to this with respect to lambda value g of lambda star using this dual problem. So when the solution which we got through dual problem is less than or equals to the solution with respect to the primal problem, then it's called as weak duality. When f and g both are convex functions, then what happens is, then we'll have that g of lambda star equals to f of x lambda star. That is the solutions. I mean the optimal solution which you find through primal or dual, both are same. Okay, is it clear? Hello, is it
Sir,
clear?
for strong duality, how g of lambda star equal to f of x star.
Yeah, that is a condition. Okay,
Sir, how that will be equal for strong duality? How that is equal?
okay, the reason for this is out of the scope. Like, I mean, out of the scope of like this course. Okay, the proof
Okay,
for this
sir.
was not even like mentioned in the lectures too. Okay, but
Okay,
then
sir.
if you have this the pictorially, like this is a f of x1 and this is g of lambda function, and then when we have the gap over here, right, that is the optimal value. That is optimal value is in this using the primal and dual. If there is a difference between those two, then that is a weak duality. And you can see in the second graph here that that both of them match. Okay, that both of them match. So that is a strong duality. Okay.
Sir, if both matches, then what is this? This is strong duality or weak duality?
Yeah. It is strong duality. That's it. When
Okay,
both matches, that basically means g of lambda star equals f of x star, right?
Yes, sir. Yes. Right.
Okay. Next we
Sir,
have this.
Sir,
Yes.
Miss, just I want to clarify my doubts. Primal problem is the original problem.
Yeah.
Original one.
Yeah.
And since we cannot solve it, we have converted that primal into the dual problem.
Yes.
And that then dual can be the weak duality and the strong duality. So in the weak duality, the solutions which we will get after converting into the dual problem, that will not be exact as per the original problem.
Right.
And in case of the strong duality, the solution will be same as the original problem.
Yes.
Is it means we can we compare like the projection problem? Since we cannot project the in that matrix problem, so we opted for that projection part. So is it similar to that projection?
Yeah. It is kind of similar to that. So like since we are not able to solve it directly, we are using the indirect way to solve it. Yes.
Okay, sir.
Okay. Yeah. After this, we have this Kkt conditions. Okay. The Kkt conditions, which what that says is we have this. It is a generalized solution for this for this one. Okay, for this one for this gradient of f(x1). Okay, so when we have this constraints to what we should be doing is, so we have this Lagrangian of f(x), right? Lagrangian of x comma lambda, right? So the gradient of it should be equal to 0. Okay, when at the optimal value. So the gradient of f(x) plus lambda into gradient of h of x. So we have only one value, that's why we have mentioned it as lambda. But then like if you have like so many constraints, so many inequality constraints, then we have this sum of the gradients of this ui into gradient of h of x plus sum of gradients of vj into gradient of l of x. This l of x is this condition of equals to 0. Okay, equals to 0. Okay, so that should be equal to 0. That is the first condition. That is the first condition. And the complementary slackness equation is this ui ha should be equal to 0. Okay, the ui ha should be 0. That we have got it by this condition, right? When h of x is less than 0, what we did is we made this lambda 2 be 0 such that Lagrangian of x comma lambda is equal to 0. Okay, so at the optimal value we have this ui ha equals 0 for all I. I mean that is true for all the inequality constraints. Okay, the primal feasibility one is this h of x is less than or equal to 0. I mean that is just the initial condition itself. Okay, and all these constant values ui should be greater than or equal to 0. Cannot be less than 0. Okay, so using this 4 equation we can solve for any problem. Okay.
Sir, miss that complementary slackness part,
Yeah.
I'm not able to understand. Sir, is it that gap part that means the what is the complementary slackness, sir?
Okay, so yeah, when I'm talking about this Lagrangian of x comma lambda, and then like when I'm talking about this maximizing of this Lagrangian of x comma lambda, right? You have seen that when h of x is less than 0, what I mentioned, since I want to maximize it, I made lambda to be 0. Okay, I made lambda to be 0 such that lambda into h of x will be 0. So that the maximum of this L of x comma lambda is going to be equal to f of x, right?
Yes, sir.
You remember that is the same thing. So what we need to do is when h of x is less than 0, we need to make this lambda into h of x should be 0. Okay. Lambda into h of x should be 0. So this lambda into h of x is nothing but this h.
Okay.
H, right?
Means instead of lambda, we have many lambda. So we are saying that it is the means u.
Yeah,
Okay.
yeah,
Instead of lambda, we are saying that it is a u. Okay.
Right. So this should be true for all the inequality constraints. Okay, because all those values should be equal to 0. Okay.
Okay. Got it, sir.
Yeah.
Thank you, sir.
And yes. Okay. So this primal feasibility anyway we note. This is the conditions which was mentioned, and this ui is this lambda I. Like it is just similar to that. So that should be greater than or equal to 0. Okay. So using
Sir,
this.
how?
Yeah.
Sir, how ui is greater than or equal to 0, sir? Dual feasibility. Can you explain that?
That is that. I mean, like while having this lambda itself, we just mentioned that lambda cannot be 0 because I mean lambda cannot be less than 0 because if you have this lambda to be less than 0, it gives us like infinite number of possibilities. Okay.
Yes, sir. Yes, got it.
Yes.
Got it. Basically, we are generalizing this equation only. Kkt is same as this one. Only miss in this problem we are saying that lambda miss cannot be negative. So in the general, okay, sir, got it.
Okay, so we'll just look at like one normal equation. This graph thing we need not look at it because anyway you will not be able to draw graphs, okay, in the function because drawing for graphs is like slightly difficult for you. So what I would suggest is solve for this f double dash of x. Okay, f double dash of x. I mean, even like any function, right? Even if they ask you like f of g of x whether that is convex or not, okay, equate that f of g of x to be equal to h of x, right? So find the double derivative of this h of x. Okay, then for all values of x, if the h double dash of x is greater than 0, then you can say that h of x is a convex function. Okay, so drawing graphs, it's not the ideal way for you to solve in the examination, especially when the functions are complex. Okay. Okay.
Sir, so, double derivative should be greater than 0 or greater than or equal to 0.
It should be greater than 0. Greater than 0. Yeah. Okay. So now, okay, now we have this. Now we are coming for this finding the W star, that is optimal value. Okay, for this linear regression. Okay, using this W1 equals to 0.1, right? They are asking you to find the optimal value. Okay, sorry. Yeah. So what we have is we have this gradient of f of x, right? So we have this gradient of f of w to be x transpose x w minus x transpose y. Okay, using that, okay, yeah, using that we can find this gradient of f of w. Okay, for each iteration as the w value varies. Okay, we can find we will be able to find this gradient of w. Using the gradient of f of w, we can find this w2 equals to w1 minus eta t into gradient of f of w. Okay, using this we'll be finding w2. Okay, for w2 we'll be finding the gradient of f of w2, and then we'll be finding w3. The process will be repeating. Okay, is this clear? Okay, like in the problem, in the actual problem, we will not be asking you to find the actual solution. I mean actual solution directly. At least using the gradient descent, because that might take like so many iterations, and we might not actually reach the like exact solution even after so many iterations. Okay, like we might only come close to it with an error. Okay, but we might not reach the optimal value. Okay, so now we'll solve for one of this problem of this optimizing 3x1 plus x2 with respect to the constraints. Okay, so we have this constraint of x1 minus x2 plus 4 less than or equal to 0, minus 3x1 plus 2x2 plus 10 less than or equal to 0. Okay, so if you have only this only when you have this two dimensions, right? You can just directly use the graphs to solve it, or else you can solve it this way. Okay, this is the first stage of x, and this you can consider as, like they have mentioned it g1, you can consider it as h1 itself directly. Okay, so this is h1 of x, and this is h2 of x. Okay, we have this u1 u2 which we need to find. Okay, we do not know the value of u1 u2 at the optimized value. Okay, so the stationary conditions, what do we have? The stationary conditions, we have this gradient, right? Gradient of f should be equal to 0, which basically means that dou f by dou x1, dou f by dou x2 should be equal to 0. Okay, when we do this dou f by dou x1, what do we have? First of all, what do we have this as? What is the Lagrangian value? So it will be 3x1 plus x2 minus plus u1 into x1 minus x2 plus 4, right? Plus u2 into minus 3x1 plus 2x2 plus 10, right? Okay, that is the Lagrangian one. And then when you differentiate it with respect to x1, that is partially differentiated with respect to x1. We have this 3x1 plus x2. If you differentiate it, you get 3. Okay, with respect to x1 since we are doing. And then with respect to here, we have what do you have? You get u1 into this is the entire derivative, it become only 1. Okay, so you have plus u1 minus 3 u2 equals 0, and the other equation will be when you partially differentiate it with respect to x2, you have 1 minus u1 plus 2 u2 equals 0. Okay, so instead of going for this u1 equals 0, u2 equals 0, and then like assuming it and solving it, right? What you can directly do is, since we have only since we have only u1 and u2, and then we have two equations. Okay, and then we have two equations, you can directly solve for u1 and u2. Okay, so what we get is, we get as u2 as 4 and u1 as 9. Okay, like by just solving this, if you just add these two equations, we just add this 1 and 2 equations, what you get is, you get minus 3u1 plus 2u2, which is nothing but minus u2 plus 4 equals 0 you'll get. So which basically gives u2 equals to 4. Okay, u2 equals to 4, and then if you substitute u2 equals to 4, you'll get minus 3 4 12. Yeah. Yeah. -12 plus 3.
9.
9. Yeah. So U1 equals 9. Okay. U1 equals 9 and U2 equals 4. Those are solutions. And then we have this primal conditions, right? Primal P is equal to 1. UIHA should be equal to 0. So for complementary slackness one, we have UIHA should be equal to 0, which basically means that U1 into x1 minus x2 plus 4 equals 0. Okay. U1 into x1 minus x2 plus 4 equals 0. U1 is not equal to 0. So x1 minus x2 plus 4 should be equal to 0. Okay. Yeah, x1 minus x2 plus 4 equals 0. And then we have this U2. U2 is also not equal to 0. U2 is also not equal to 0, which basically means minus 3x1 plus 2x2 plus 10 should be equal to 0. So by solving for these two, equations itself, we can get x1 and x2. Okay.
Sir,
yeah.
Sir, in this kind of problem, we will never find U1 and U2 or like U to be negative. They will be always be positive, na?
Yeah, the condition is that U1 and U2 should be positive. Okay, if you're getting U1 as negative, that means that your solution is like wrong.
Suppose in the given problem, up to the equation 1 and 2, we solve for 1 and 2, and we get the negative values of U. Then means we are making something wrong. U1 and U cannot be negative.
Yeah. Okay, sir.
So does that mean the solution cannot be minimized, right? So
yes, yeah.
Then it cannot be minimized.
Yeah.
Okay, means if you use U1 and U2, any of that comes into the negative, means we cannot we can not feasible solution.
Right.
Okay, sir.
Okay. So what we have is we have this complementary slackness, and then by solving for these two itself, we can get this x1 and x2. Okay, we can get this x1 and x2. So which gives us this x1 equals to 18 and x2 equals to 22. By substituting this x1 equals to 18 and x2 equals to 22, we'll get the minimum possible value of 3x1 plus x2. Okay, clear? Is this clear?
Sir,
yeah.
Can you explain one more time how you got the stationary conditions?
Stationary conditions?
Yes, sir. Yes.
Okay.
Please
this one, we have
yes,
this.
Sir, yes.
Okay, wait. So this is 3x1 plus 3x2, right? This is f of x. I mean, this you can assume it as f of x, right? And
yes,
this one is what? This one is h1 of x, and this is h2 of x, right?
Yes, sir.
So h1 of x into u1, and this is h2 of x into, like, you can just assume that there is u2, and then like you can multiply it. Okay. H1 of x into u1 and h2 of x into u2. Okay. So we have this Lagrangian of x comma lambda as, I mean, x comma u as f of x plus u1 into h1 of x plus u2 into h2 of x, right? Now we need to differentiate it with respect to x1 and with respect to x2 and equate it to 0, because the gradient should be 0, right?
Can't understand, sir. How you are speaking?
Hari, just I'm saying our original equation is to minimize the function, some function, and there are some constraints. So by combining that original condition and the constraints, we make the Lagrangian function. Okay.
Yes. Okay. Yes.
And then we differentiate Lagrangian function so that and make it to 0.
Okay. Yes.
Got it. And
yes.
We are differentiating Lagrangian function with respect to x1, then with respect to x2, and making it to 0. Both of them.
Okay. So we got the both two conditions.
Yeah.
Yes.
Okay.
This is the stationary condition.
This is stationary condition.
Okay. Thank you. Got it.
Yeah, and from there we got the remaining ones. Okay. Yeah. That's all I have. So if you have any other questions, you can ask. So one thing I want to say is for the further final quiz, you won't have any questions with the constraints. Okay. With the constraints, you won't have any questions for the final quiz. So which basically means until until solving for the linear regression, right? So using gradient descent and the stochastic method. Stochastic method also we not have because our data will anyway be small. So until the linear regression and solving for the W value using the gradient descent, that will be I mean from those you will getting the questions. Okay. So
sir, we had solved for the one minimization problem. Sir, can you solve one maximization problem? The original condition is maximization of some function.
The maximization.
Yes, sir.
We can solve it, but the thing is, I've already told that we'll not be having any such questions of it here, and then we need to look at the other weeks also. So okay.
Okay. Means this kind of problem will not be having in the final term.
Yeah.
Okay, sir.
Okay. So Vishal, can you take the next weeks?
Yeah.
Sir, just want to confirm one more time that KKT problem will not be in the final term.
Yes.
Okay, sir. Okay. Thank you, sir.
Okay. So, are you able to hear me? Okay, I'll share my screen now.
Yes, sir.
Okay. So for the last 3 weeks, most of you would have done, I guess 2-3 times you would have read. So I'll just go through the slide once, and I'll briefly tell you which are the most important, you can say, for the exams, because we can't go through each and every slides. Okay, for the 10th, 11th week, it's sort of everyone has done it twice or thrice. Okay, so if you'll be having any doubt, you can ask. Otherwise, I'll just go through the slides itself. Okay. And for the last week also, I'll just tell you the important one, because there are so many concepts in that last week also. Those concepts you can read for the knowledge point of view, and there are some sort of I'll just tell you which are the topics from where that questions can be asked. There are questions where theoretical question can be asked, but there are no theoretical questions in the final exam. So mostly you'll be having the mathematical type of question. So I'll just share my screen. I'll go through each weeks of content. And yeah, so okay. And one more thing, the formula sheet I'll just show you once. So this is the formula sheet you'll be getting in the exam itself. And this has been uploaded on the Discord also. Just the basic probability formulas and the basic Chebyshев and Markov's inequality and CLT theorem and maximum likelihood estimation. Okay, so this is, I guess, this will be there in the in the question paper also. So if you are not able to remember the basic formulas of probability, there you would have remembered already, but the basic formulas will be there in the formula sheet. Okay, so is this fine? You're asking on the Discourse also. So Jimmy has uploaded there also, but if you want to see that, you can see this. These are the basic.
Same sheet that is available in statistics, right?
Oh yeah, this was in the statistics. There was lots of more formulas, but I've just cut out the formulas which are not useful in the ML.
Okay.
Yeah. So more or less, this is the same formula, but there are other Bayesian estimation and all where they're in the statistic. Those I've just cut down from because those are not helpful. Okay. So the likelihood, maximum likelihood, you already know, but yeah, it will be there available in the formula set. Okay, then I'll go. So yeah, so in the 10th week, mostly we are discussing regarding the discrete sort of things. Okay, so what is in the first lecture? I have not made the notes of this because there's no point of making notes out of 10th and 11th week. Okay, because the formulas only you can write the formulas, right? Or else you can, if the basic concepts are clear, the question whatever you'll be getting is sort of you'll solve it most probably because the questions are pretty simple from this week's 10th and 11th.
Yeah, sir, I am struggling here when the questions A union B union C, some questions like those, I'm not able to answer.
You have directly came, you have not done statistic.
No, means yeah, I have done, but no, I came in directly in the diploma.
Okay, you have one done. Okay, so you can union and all is a very basic problem. But okay, if
Yeah,
you are having
whatever
any,
I apply. Yeah, can you try solving one problem in activity question 10.1, question 5?
okay, I'll just go through that, but till I'll just go through the slide once and then I'll take your question. Okay, is
Okay,
that
thank
fine?
you. Yeah, fine.
So in the first like the first lecture, there was nothing, just the sample space. You already know what a sample space, the event and sets, power sets, sort of things. Okay. So there is not much. If you're having any issue, you can just point out at that time, because I'll just go in a very good speed. Okay. Because there is not much to discuss in that. Maximum probability, you already know that the probability of all the events should be equal to 1, and for each of the events it should be greater than 0. And if you are having n disjoint set, then for the disjoint set there won't be anything in the common between them. Okay. And for the independent set, there can be some sort of things which are common, but the one thing that is important in the independent sets is the intersection of those will be the multiple of the product of the probability of both the term. Okay, but here the intersection will be 0. So that's the difference between disjoint and the independent set. Okay, and there not much is there. Yeah. So this type of problem we're asking, the union is A plus B minus A intersection. This you can solve with the set, what you can say, basic set questions that you would have solved in the maths and on like class 8th and 9th. Okay, and then this is yeah.
Sir, mutually exclusive and disjoint set. What is the difference between them?
Mutual inclusive and
Disjoint set.
this is just a basic formula. Disjoint is like if you don't have any. This is a what you can say the method to come to one conclusion. Okay, disjoint is a what you can say property where if you are having two sets which are disjoint, then there won't be anything common between them, right? Like
And the same definition is also applicable for mutually exclusive.
mutually exclusive. Yeah, both are same.
Both are same.
Sorry, I'm talking about the exhaustive set where there won't be any mutually exclusive. Is like the like if you're tossing a coin, right? So you'll be having head and tail one. That is mutually exclusive. Okay.
Yes, sir.
Right. And the disjoint is that you are not getting like anything in common between them. And
because in the lecture slide, professor wrote that if two events are mutually exclusive, if their intersection is high.
If two
events are mutually exclusive if their intersection is high.
Yes, yes.
Mutually exclusive, right?
Yes, sir. And the same definition is for
the disjoint also. So that is why I've told you both are same. Like mutually exclusive event, there is nothing common in between them. The disjoint is also the same.
Yes.
Okay. Yeah. So is that fine? Like both are same, mutually exclusive, and that disjoint set, but independent are different. Like okay. Yeah. So is there anything else in this? I don't think so. There is anything. So in the second lecture, you are been taught regarding the conditions like conditional probability, the A condition B. So this is a pretty simple formula for the condition probability, and then he would have solved some of the examples. And the total probability law is like all the probabilities will be equals to 1 and all, right? Yeah, this is mutually exclusive, right? The intersection is 5. Okay, and exhaustive means all the subset will equal to the all the subset will equal to the sample space, right? This is exhaustive. Okay, so yeah, so you just solve some of the problem. You can just solve some questions from the practice and grade it, and it's fine, I guess. There's not much. I'll just solve that question you was asking, which was that. Okay. Yeah. And whoever was asking the slides of this, so there, see, in the 4th week, that was in the quiz 1. So these are the 1, 2, 3, 4 revision slides. Okay. And for the quiz 2, like 5th week slides are there, 6th week slide is there, For 7th week, there was no like slide. And for the 8th week, I guess there is that will upload it, right? And for the 9th week, we'll upload that. And 10, 11, 12, there is no slide because those topics are not like you can just go to the search lecture, like slides itself, because there is not much in that. You just have to practice this 10th, 11th, right? So I'll just go through that. Okay. So 10th, which question? Activity 1? Practice.
10.1, question 5.
So you can just take C. B union C is there, right? So
Yeah.
just take this B union C as D. Okay.
Yeah.
So the probability of A is 0.2, probability of D is 0.6, right? And you have to calculate the probability of A union, probability of A union D, because we have taken this B union C as D, right?
Yeah.
So the probability of A union D is what? 0.7. Now you have to calculate the probability of A intersection D. So A intersection D is what? You can directly write A union D is what? Probability of A plus probability of D minus probability of A intersection D. Should I write, or are you able to get it?
Yeah, got it. Yeah.
Right? So you can directly write it like 0.6 plus 0.2 is 0.8 minus 0.7 is 0.1, right?
Got it.
Yeah. So you can do it like this. If you are facing problem whenever there is 3 terms, so you can make 2 term as 1 term. Okay. In that way you can solve.
In that case, it will come at minus 0.1. Or
No.
minus will cancel. Okay, I got it.
Yeah, minus.
Yeah.
If you're writing in that way, okay. Otherwise, yeah.
And one more on 10.2.
Probability cannot be in the minus.
What?
In any ways, a probability cannot be in the minus.
Yeah, can't be minus, but he's doing some correction. Like I think so. He has taken A intersection of D. He would have written. That's why he's getting minus. Yeah.
So next one is similar later 10.2 question 4.
Question 4. Okay, this one. This is a simple formula for A intersection B are the 2 events with both the probability are greater than, because the following is equal to intersection of this. You can write it, right? Just write it. What is the probability of A intersection B? In the term form, just see in the conditioned form, write it in the form of condition. How generally you write A conditioned of B? Probability of A intersection B upon probability of A, right?
So not this one, next one, 5th one.
5th one is also same. Both are same. Only the thing is here you have to write the condition from probability of B given A, means the denominator part will be always A, right? And the upper part will be A intersection of B, right? So the numerator part will be A intersection B, and the denominator will be probability of A. A intersection B, you can write it from this form, right? So you'll get 2 answers here, because you can write this A intersection B from probability of B given A also and probability of A given B also, right? So you can get 2 values of probability of A intersection B. That you can write, you'll get 2 values. Are you able to get it?
Yeah, can you write it like? Okay, I tried to, it was not like I was not able to grasp it. So if you can write it and then explain it.
So, okay. So I'll write it. Okay. So what was that? Probability of B given A, right? So this you can write like this. You can write like this, right? And this also you can write. Probability of A given B is what? Probability of A intersection of B. Probability of B. You can write. Right. This value you can write it from here also. Or this value you can take out like the cross multiplication of this. And you can put it here, right? You can put like write like this. A into probability of B by probability of A. Right?
Okay.
Yeah.
Okay. Okay.
But try to solve some mathematical question, because mostly the maths type of question will be there. Okay, like for example, I'm giving you one example, like this sort of, yeah, these are the simple formula. There should be, this all should be in your mind. Okay, like you'd have solved some problems, like if you're having a two bag, okay, and one bag is having 5 white and 3.
I tried those.
Yeah. So those sort of problems, just try some, because I guess if you're facing in this type of questions, just try this sort of questions. Okay, 2-3 questions. Okay, so that will make you a bit confident.
Right.
Because there will be questions from 10th and 11th. At least two questions will be there from each week, and those questions will be a bit good. Yeah, so you can practice some question and you'll be able to solve that. That I can guarantee. If you are able to practice some sort of questions, you'll be able to solve. Okay. Okay. So just practice some questions from, I'll write the important topics also. To practice some question from Bayes theorem. Bayes theorem, and one is this one. And then you can practice some questions on random variable. Okay. And then simple joint distribution. You know, this consists of very, like, it's a, just I'm writing a joint distribution. You can solve some questions that are there in the practice also graded. Just solve it 2 times. I'm sure we'll be able to do that. Okay. Is that fine?
Yeah, fine. What will be the weightage of these 10 and 11 chapters?
There will be, I guess, 2 questions and 2 from each week.
Okay. Thank you.
So, yeah.
So there will be less question from week 12.
Week 12 was pretty simple, right? So you can have 2 or 3 questions from there. So I'll just tell you what to revise. Okay, from 12th week. Don't get panic. Like, if you're not able to grasp the concept, what you can do is, I'll tell you the important topics that you can practice at least to solve the question. There are some concepts that maybe you did not came in the live session. We have discussed some, like nobody was asking those questions, but I will tell you today the important topics that you can practice. Otherwise, you'll be able to solve that question. So mostly today I'll just give you the important topics and all. So I guess week 10, yeah. So week 10, where was I? So week 10, 2 lectures have been discussed. And the third lecture, we have just talked about the random variables. Okay, so random variables, you already know regarding this. Like, you can, like, if you have been told to, like, for example, in this problem, we have just tossed the coin twice, right? And we were having this 4 as an outcome. And we have just defined headed. Whenever you are getting headed, you can just define it as 2, and head tail as 1, and tail head as 1, and TTS. So this type of question you can expect. You can expect, like, yeah, we'll just define some sort of things like this is the outcome, and with that outcomes, we have defined the random variable, and with respect to this random variable, like, for example, here we have defined this. And now you have been told to do some sort of, what you can say, some more steps, like those will be able to do. But the thing is, you should be aware of that, how generally that random variable thing generally work. Okay. So this is the base examples where you are just tossing the coin twice. And then if somebody has told you to how, like, define, somebody has defined, like somebody is asking you to, like, X is the random variable where, like, if I'm tossing the coin some sort of times, like, for if I'm tossing, what you can say, tossing the coin 5 times, and random variable X is like the number of head, like if I'm getting 3 heads, that is the random variable X. And if I'm getting the 2 tail, or you can say 3 tail, that is the some other random variables. Those sort of things can come. So if you're able to get some problem in those, you can practice those. PMF is that probability mass function, and CDF, like for PDF is like the density, the probability density as some particular value. In this chapter, we are just talking about the discrete one. So for each of the discrete value, there will be some PMF for each of the values. Okay, and the CDF you can calculate by just summing all the term till that point. Okay, if you have been asked the CDF for x equals to, like, for example, 2, then you have to sum the PDF of all the values before 2, or you have to take the 2 also. Okay, so this is the simple PDF and CDF, like, and each of the value will be from 0 to 1, and the range of the summation will be equals to 1, because it's the basic probability, or what you can say, the property. And the CDF is simply for infinity, it will be 1, because the CDF function generally will go to 1, that it tends to 1, right? So that's why at infinity, the CDF function, the value will be 1, and for the minus infinity, it will be 0, because at minus infinity, there won't be any, what you can say, density function, and that's why the density at minus infinity, it will be 0. Okay, and the CDF is also from 0 to 1, because every time we'll do the summation of some parts, it will be less than 1, because in the end the summation should be equals to 1, right? So that's why every time we'll do the summation, it will be between 0 to 1, and in the end it will be 1. Okay, so this is a basic example of how to, like, this is a basic example of what you can say, and the indicator and a variable is simple. Like, for example, we were defining some random variable, right? So here it has been defined. Indicator is in the form of, like, you can say, the Bernoulli yes or no sort of things. Like if I'm tossing a coin, okay, and if I'm getting 2 head, I'm defining it as 1, and if on the all other cases I'm defining this as 0. Okay, this is a sort of Bernoulli. Yeah, either you are getting the success or you're not getting my success here is if I'm tossing the coin twice, and if I'm getting both the head, that is my success. Okay, so that is the indicator and a variable. So this is a simple, or you can say, the concept. There can't be any question from this sort of things. And there's a functions of random variable and all. So if you are able to do that, okay, it's fine. Like, for example, you have been asked regarding, you have to calculate the everything for the y equals to mod of x minus 2. So what you can do is, you can write the PDF for all the x, and then for x minus 2 you can write, okay, the simple form, like basic examples and all. You can do some sort of examples from the practice if there is some, and then we'll move to the expectation variance. The formula for all the distribution will be there in the formula set, but you should be knowing how to calculate the expectation. Like, expectation is simply the average value of all the with, like, for if you have to calculate the expectation for some function, the discrete form, you just have to add with the probability and that point. Okay, and if that is in the continuous, then you have to integrate with the function and with that value. Okay, so this is the basic difference between discrete and continuous. And expectation can be calculated simply, and for the all the functions that all the different distributions, the expected value will be there. Like, for example, if I'm tossing, if I'm throwing 2 dice, okay, and the sum of the faces we have to get, the expectation would be 7. Like, the expected value that will get if I'm throwing the coin, if I'm throwing the dice, 2 dices, the sum of the numbers that I'll get in the front face of the thing, dice, will be 7. So this is a simple, like, and the one more important thing is the expected value can be different from the outcomes. Like I'm throwing the dice, I'm getting the expected value as what, I'm getting the outcome as what, from 1 to 6, but the expected value is 3.5, because the expectation is the average value. Like, if a batsman is if a batsman is facing 6 balls, so for example, he can score from 1 to 6 1, like he can score 5 runs also. So what is the expected value, expected run that he can score of a single ball? So that is 3.5. Okay, because how we are calculating, because the probability that he can score 1 run or 2 or 3, 4, 5, 6 is 1/6. So, and we are multiplying with each of the outcomes, like for 1, 2, 3, 4, 5, 6, and we'll get 3.5 as the average value that he can score of a single ball. And that's the basic what expected value. The variance also, you'll see the variance also, and these are the basic properties of the expectation. If you're having to, like, in the expectation, if that x and y are independent or not independent doesn't matter. The summation of the, if you have been asked to calculate the expectation of x plus y, that will be simply expectation of x plus expectation of y, and that if that x has been multiplied with some constant, that constant will come out right directly. And the variance is simply the expectation of calculating the x minus ex of x square. That the final formula I should remember. This is the variance of x. That is the expectation of x square minus the mean chi square, or you can say the expected value of x chi square. So this is the simple formula for variance. Variance is what? This is the simple expectation of x square minus the mean chi square. That is the variance of x. Okay. And then the fifth one is in the fifth lecture, he has just talked about the joint distribution. If you have been given two random variables at a time, okay, like x and y and both, okay, and then how to calculate the probabilities and all. So there's basic, what you can say, like for example, there's a table. Every time if you are solving the discrete problem in joint distribution, you should be able to draw one table, okay, and with that table you'll be able to calculate directly. Like for example, if I've been given some problem, I've just plotted this table, okay, and if I'm having this table, you can directly what you can say, to calculate the value. Like for example, if I've been told whenever the x is 3 and y is 2, okay, so that directly I can see that 2 upon 36 the value. If I'm asked to calculate the marginal distribution also, like for example, if I'm asked y equals to 2, okay, so what you can do, y you have to fix it, like y you have to fix it with 2, and then you have to do the summation for all the x, right? So you can do the summation for all the x, and you have this is the marginal distribution for y. So for each of the value, you can calculate the marginal distribution. Okay, if you are able to plot the table, you will be able to solve each and every questions related to joint distribution. Okay, and the simple formula marginal distribution, just you have to fix. If you have been asked to calculate the marginal distribution of y, you have to just fix the value of y and then do the summation for all the x. If you have been asked for, and vice versa, if you have been asked for the x, you have to just fix the value of x and do the summation for all the y. And the conditional provides that the difference between the conditional and the joint, that the conditional in here you have to condition the y. If you are conditioning the y, that means that will come in the denominator. The denominator part is what? It's the marginal distribution of y. If you are fixing some value, like for example, I'm fixing 2, then y equals to 2, and then you have to do the summation for all the x. And here it is the joint distribution. If you have been asked to calculate the joint distribution of 2, 3, that means y is 3, and you have to calculate, you have to fix the value of y equals to 3, and then do the summation for all the x, and you'll get the marginal distribution. And then you can calculate the joint distribution, divide it with the marginal distribution. Okay. So the simple formula, if you have to calculate the condition, so joint is generally every time you will do in the future also. If you are doing, you have to calculate the joint distribution. You have to multiply the condition through marginal. Okay, so the CM you can remember, CM is equal to Z. Okay, the joint distribution, if you have to calculate, you can just multiply condition with the marginal distribution. Okay, this is the basic what you can say, the some example is taken. These are the what you can say, if they are independent, you can and one more thing, if they are independent for all the points, it should be coming, like for example, I'm calculating for probability of 2, 3. Okay, and if you are calculating for 2, 3, then the probability of x equals to, if you have calculated the marginal distribution fixing x equal to 2 and calculating y equals to 3 fixing y equals to 3, the product should be the value of y equals to, like the probability of x equals to 2 and y equals to 2 on for each of the values, not for only one. And for any value, the product is not equating to that of the probability of x equals to some x and y equals to some y, then it's not a independent. It's not independent. Okay, so it's a dependent one. But if you are getting first some, I told you, like there was one question also in the discourse, like somebody was asking why that B option is not correct. There was a question in that in our practice or graded assignment in the activity set also. So there it was written for some x. If that is for some x, that can't be independent. Okay, it should be for all the x, then only it can be independent. Okay, and that there is no error in that portal. So that portal, the question is correct, and the options are also correct. So for if that is for all, if coming like the product value is equals to probability of x equals to x and probability of y equals to y, and it is true for all the values, then you can say it's independent. And if that is not true for even one value, can't be, so it's a dependent, not a independent. Okay, so then there is a covariance formula, and if that x and y are independent, the covariance, like if the interrelation, that the relation between both the variables are 0, this is a pretty simple one.
So one confirmation.
Yeah.
The expectation E of x, y, where x and y are independent, equal to ex into ey, when X and Y are independent for all the cases, right?
Yeah.
We have
If
to check.
X and Y, yeah. If X and Y are independent, then only you can write like this. Okay. Otherwise, you can't write.
And if we find in another side, like E of X, Y equal to E of X and E of Y for one case, and for other cases, it is not valid, then it is not independent, right?
No. What you are asking, expectation of AX and expectation of AY.
Sir, can you move up little up? There was this type of formula. There was also like independent of X.
Here. Where? Here.
So little up, I think.
Here.
Yes.
Yeah. So if that is independent, that is what I told you. If that is independent, the fxy will be equal to fx into fy for all the values. That is to remember, for all the x and all the y. Even it's not like this condition is not true for one x, then this is not independent. This is a dependent. Okay, that's the one thing. And if that is independent, then this is correct. Expectation of gx or expectation of hy will be equal to product of both the expectation. Okay. For the summation, if this is for E of gx plus hx, hy, then you can directly say for whether it's independent or not independent, that will hold true. Like the expectation of gx plus expectation of hy will be equals to expectation of gx plus expectation of hy. Are you getting my point? For the
yes,
product,
for the multiplication, it will be
it should be independent. Then only it will hold. Okay.
Understood.
Yeah. So these were there, and then we'll come to the variance part. Okay, so these are simple. For the variance, the properties are like, if you are having independent, then only you can write x variance of, like if you have been asked to calculate the variance of x plus y. If both are independent, then only you can write variance of x plus variance of y. Otherwise, you can't write. But in the expectation, you can write in either way, like whether it's the x and y are independent or dependent or independent. Okay, so you can write in both the cases, but for the variance, you have to check whether x and y are independent or not. Then only you can write. Okay, and these are the some distribution, like for the Bernoulli distribution. What's the variance and what's the expectation? These are all will be there in the formula sheet also. And if you want to go to that, you can go through that. It's not, these are not that much of important because all the things will be there in the formula sheet. Okay. So I don't think so. From 10th week, I'll tell you the important. I'll just write some where the important thing should be. They solve some problem related to Bayesian theorem and the random variables. Okay. And then just should be, if you have been given some PDF of two like multi-variables, so you should be able to plot the table of joint random variable. So this you can solve, you'll be able to solve the question. Okay. For 10th week, this is for the 10th week. And I'll write it for the 11th week also here because both are same almost. Okay. So for the 11th week, yeah, one thing I must tell you, everyone is aware of that convolution theorem, right? Like if we have been given one
max min,
yeah, what
max and mean of random variables, sir.
Basically, it is for the transformation of the random variables.
Yeah. So for example, if you have been given x as one, what you can say, this rectangular function 0 to 1, okay, and you have been given y as 0 to 1, okay. So, and if you have been asked to calculate z equals to x plus y, what would be the plot of this x plus y? This you are able to do that. Are you able to do this? Or should I tell you the direct formula how to do this rectangular sort of thing?
Sir, please tell us.
Okay, the method, I don't know if you are doing, you know or not. The method is pretty simple. what you have to do if you are having this function, any function, like for example, I've given you the rectangular function. What you have to do, because you generally write this as this f of this convolve to f of y, where you will write z minus x. Okay, so z minus x means what? You have what you have to do. You have to 3 steps are there mostly. If 3 steps are there, this is not the shortcut. This is not the shortcut. I'll tell you the shortcut also to directly do that. The proper method to do is that you have to just take the inverse of this function and slide it with x. Like the inverse of this function is what? This function. Okay, so this would be the, what you can say, not inverse, the minus of this function. Okay, so this, and then you have to, what you can do, you can slide with this function. If you'll slide with this function, that means what? I've just taken this graph. This is my plot. This is the y naught y minus y. Okay, and then you have to slide with this function. If you are able to, like for example, till this value, there is no overlap. Like if I'm sliding from minus infinity and just I'm fixing this function, I'm just sliding this function from minus infinity. I'm sliding till this value, there was no common between them. But if I took some value, like for example, like 0.5, if I'll take this value, like 0.5 would be here. So there will be some overlap in them, right? So there will be overlap. So we can calculate the area whenever we are getting the what you can say, we are getting the common area. Okay. Again, if you'll slide for little bit more, we'll get some more values. And similarly, we are sliding it here. Okay. So what you'll get, see, if you are having the value, you're sliding. Okay. So till the value, till the t is 0, like if I'm taking this till here, the overlap was 0. So till, so minus infinity to here, or you can say after sliding, after 1, again, this function, if this function will come here, the common area will be 0, right? So you can expect there will be some sort of values. After that, the PDF will be 0 for us. And before this, till this value will be 0, right? And whenever there will be a total overlap, at that time, the overlap, the area will be maximum, right? So there will be some peak point, right? And whenever the overlap will be lesser, at that point, the value of the overlapping, the area will be lesser. Are you getting my point? Whenever the overlap will be total, at that point, the area will be maximum, right? And whenever the overlapping will be lesser, then the area will be lesser. That means this is a sort of triangular thing, right? Because, and there is a, what you can say, there's a symmetry also, because this is a, both are having, what you can say, same length, right? 0, 1, 0, 1. That's why. So this is a symmetry, and this value you can calculate. And what would be the this value? So this value would be, I'll just tell you. Okay. So this is the proper method how generally we solve convolution. Okay. This but now we'll talk about the shortcut. How can you just directly write if you have been asked to calculate this? Like for example, if I'm having this rectangular plot, 0 to 2, and this you have to convolve with this rectangular function 0 to 2. Okay, so here it will be 1 by 2, and here it will be 1 by 2. And this is x, and this is y. And this is important. That's why I'm telling you. Otherwise, I would not have. So please be attentive for this. You can get some questions around this. So this is important. When you have to calculate the PDF for x plus y, what you can do directly, you can just sum all the values. Like this is the lower end, this is the lower, this is the upper end. This is the lower end, L1, this you can see L1, U1, this is L2, U2, right? So what you first do, just add all the values, like all the combination L1, L2, L1, U1, like all the combination, just do the summation with all, L1 with L2, U1, and U1 with this all. So what values you will be getting? 0 plus 0, 0. 0 plus 2, you'll get 2. 2 plus 0, you'll get 2. And 2 plus 4, you'll get 4. Okay. So what you can do? 0 is there, 0. 2 is here, 2. Here it is 4. Right. So at 2, you'll get the peak. So this will be some sort of, this you'll get at z, x plus y. And the maximum value you can calculate. Like the area under this curve will be 1. Right. So you can calculate the area directly. Have you got the point? Okay.
Sir, what if both x and y are not in the same, means 0 to 2 and 0 to 3?
Yeah, 0 to 2 and 0 to 3, right? So now you will solve 0 plus 2, 0 is 0. 0 plus 3 is what? 3, right? And 2 plus 0 is 2 and 2 plus 3 is 5, right? So now I'm getting what? 4 values, 0, 2, 3, 5, right? So what? This will be a trapezium. From 2 to 3, this will be a C.
Okay.
Right. So, and not more than them will be asked in the exam. So either it will be a same, either if they are asking to convolve something, like they'll not ask directly to convolve. They'll just ask you if this x is this function, y is this function, then x plus y. And then in that they'll ask some sort of, if somebody is not able to do x plus y even, then he'll not be able to solve that, right? So first of all, if x and y has been given, like for example, I've been given, I'll just give you one example. And just tell me if I'm been given a uniform function and that is from 1 to 5. And this is also uniform, that is from 1 to 5. So now you can tell me what would the x, this is x and this is y. And z will be a triangular phase, right?
Yes, sir. Max will be 5.
2 to 5, right? 2 to 10.
2
Sorry.
to 10.
And the peak value will be at 6, right?
Yes, sir.
Because 5 plus 1 and 5 plus 1. So you'll be getting this sort of where 6 is here, 2 is here. And if you have been asked to calculate the probability where z is less than 4, then you can calculate directly. You can calculate the area, right? So this sort of problem can be asked. So this is one more, what you can say, the most important thing I've told you. Please, you can practice this and you can go through what you can say. Yeah, practice some questions sort of. Yeah.
In the previous example, how did you get that trapezium figure? I cannot understand.
Okay, so the trapezium, what is in convolution? I've told you, like for example, this was the figure one. The shortcut method is this one. You just have to add all the values, and the basic approach how generally you get this trapezium is this method. You just have to, like, if you are having one triangular from 1 to 5. And if you are having some 2 to 6, like in this case also you'll get one trapezium. Okay, so what you have to do, you have to just invert this function. Like this will be from what, 2 to -4, and then slide this function over this. If you will slide, you'll get, for every time you have to do the calculation, and you'll get a, for that also there is a formula, like how generally if like this can be written in this form, like this I can write in this. If you have a radian signal and system, how generally we write this. This is a pulse. Okay, this in electronics, if somebody is from electronics, you would have read. This is a sort of pulse that you are passing. Okay, this is a pulse from 1 to 5. Whenever this pulse is high from 1 to 5 seconds, and this pulse is from 2 to 6 seconds. Okay, and then you have to get a pulse that is the summation of both the pulse. Okay, so how generally we get the other pulse? That is in the form of trapezium, that pulse. And that pulse, this pulse, how we can write? This pulse we can write in the form of like t plus what? T plus 1 minus, like for t, like u, t is a pulse that generally is this one. Okay, there is a pulse that denotes from, this is a pulse, this is high for value greater than t equals to 0. For time equals to t equals to 0, greater than 0, this pulse generally go like whenever, this is a sort of switch you can say. Whenever this t is greater than 0, this switch, we are switching on the pulse, and that pulse can be represented in this form. Like this is the pulse only. Here we have just talked about the function. In many times we generally talk that in the form of pulse also. So if you are having a pulse that is in the rectangular form, both the pulse having the rectangular, but both the pulse has been turned on at different points, then that pulse will be a trapezium. And if that pulse has been started both at the same time and end at the same time, that pulse will be in the form of triangular pulse. So that is one conclusion you can make directly. And if you want to go through the how generally we are able to solve this, then you have to do by manually. Just take one function, invert that other function, one function, fix the one function, then like fixing one function, invert the other function and just slide with the first function. And every time you calculate the area, you'll get the pulse in the form of trapezium if the interval is different. And if the interval is same, then you'll get a triangular pulse. I hope maybe, or you can directly write some, you can just Google it, convolution of two rectangular pulses or rectangle with different, like just write it, convolution of two, you'll get the brief explanation about that. I hope that is more than sufficient. Yeah.
So in this area calculation, if you can just come down a little, this the triangle which you showed.
Okay.
So here I have to I have to integrate from say 2 to 4, if this is 4. And with the PDF
you can get this line, equation of this line, right?
Okay.
Because this point you can get, like, because the area will be 1.
Right.
You can write directly half.
So I don't have to integrate. I can just find the equation of this line.
You can directly find this point if you are able to find, like, for example, this point you are getting. So this height you can get this, then you can directly write it. Half into what is this? If this is 4, 2 into this height.
Right. Okay. And if it is say area between say 4 to say 7, then I can subtract these two triangles and take the area in between, right?
Yeah. You can, if they've been asked from 4 to 7, either you can do you can calculate the trapezium area.
Okay.
Like you already know the area of trapezium, half into sum of, there is one formula I'm not able to recall, but there is some one formula. Or you can, what you can do, you can just calculate this area will be half of total area, like that is half minus this area, you'll get this area, right? And similarly, you can do in this. You can calculate this area and subtract this area, you'll get this area.
So I don't have to use, I mean, I can do this. I mean, it's basically area calculation.
Yeah, this is a basic area calculation.
Right.
Sir,
yeah.
Sir, I got what you told just now about this trapezium figure, but I am not. I don't want to go into the concept right now. So briefly, if I want to draw a figure, I mean, if they give this convolution, so how will I be able to do that?
See, I am just asking. One x is what? X is, you have been given a uniform function, and that is from 1 to 5, right?
Yes.
And you have been given y as a uniform from 2 to 6. Yes. And you have been asked regarding the z, PDF of z. How will you do that? You just have to do the summation. Do this summation.
That will be 3.
Right?
Yes.
You have asked this. You get 4 values, right?
Yes. 3, 7, 7, and 11.
No, for this you can't use directly the formula. You have to for use this also you can, but this will get complex. See, I'll just give you some simple example, because the simple things can be asked, okay, because they have not explained you in a much better way regarding the convolution. They can give you some sort of questions like this. This is also 1, 5. This is the simple triangular, because if you are able to sum this 1, 1,
yes,
right, and do the summation of this 1,
yes,
5.
So 2 to 10.
Okay. Getting. And then do the summation of this 5, 1 and 5, 5. So you'll get what? 2 you will get, or you'll get 6, you'll get 6 and 10, right?
Yes, yes.
So at 6, the value will be at peak, right?
Okay.
While sliding, I told you, while sliding the figure over one figure over other, I told you at this value, the peak will come, right? At 6, there will be a peak, and so this is your triangular PDF. And this is a symmetrical, every time you'll get a symmetrical, right? Got the point?
Actually, sir, I'm not trying to get into the concept right now. I'm just trying to get something out of this shortcut. Like if they give me like this, so I can see that in 6 there are 2 values. So I can be sure that at 6 I will get a peak value. But in the previous case, how can I get that trapezium?
Okay, see, there was a one question, that is if one pulse that is rectangular pulse that is from 0 to 2, right?
Yes.
And one pulse is from 0 to 3, right?
Yes. Yes.
So if you have to just do the summation of all the values, that is the upper and lower bound. So the lower bound is 0 and here the lower bound is 0. So 0 plus 0 you will get 0.
Yes, sir.
Right? And if the lower bound is 0, upper bound is 3, you'll get 3.
Yes, sir.
Upper bound is 2, lower bound is 0, you'll get 2.
Yes, sir.
And upper bound is 2 and upper bound is 3, you'll get 5, right?
Yes, sir. Yes, sir.
Okay, so what you have got? You have got 4.0235.
Yes, sir.
And you have to draw a trapezium. So how you will do that? From 2 to 3 it will be parallel to this line, and then there will be a trapezium. Okay.
From
mostly, yeah.
From 2 to 3, I will get. So if I get these different types of value, then I will get a trapezium, and if I get same value in the middle, then I will get a triangle.
If you are getting 3 points, you'll just draw a triangular, and if you are getting 4 points, draw a trapezium. Because you can't get 5 points, right?
Now this is better, sir. Yes, yes.
Okay. So I'll just move to the next part of 11. Not much. So this was the one important concept that I told you, and you can expect the question from this convolution theorem. So you can just solve some problem and you'll be able to solve the question in the exam. And mostly I'm just going through the important topics only. And from part 1 to there is not much. Part 3 is, I guess, or expectation and variance. If you are getting the expectation and variance, you'll be able to solve that. There is basic formula and you'll be able to solve. From 4th, what is that? Yeah. So the joint distribution, if you are having any issue in that the joint distribution, you already know where the x and y are some values. For the marginal distribution, there is a one difference between the marginal that I wrote in the discourse also regarding if you have been asked to calculate the cumulative marginal, or you have been asked to calculate the simple marginal. For example, if been asked to calculate the cumulative marginal of x and there x is equals to 2, that means what? You have to calculate all the values of y because that is a marginal for x. That is the one thing. And if you have been asked to calculate the marginal for y equals to 2, that means what? Whenever we write the margin, I'll just write it here. So if we have been asked for the marginal, how generally you write the cumulative marginal distribution? That is one thing that will be written in the capital form. That is the general represent that is how generally we represent the cumulative. And if you have been asked for f of x equals to 2, that means what? You have to do the integration of y from all the values, like from minus infinity to infinity. That means if whatever the label, whatever the range of y, so you have to calculate the y for all the minus infinity to infinity. And for x equals to 2 means what? Whenever we do the cumulative CDF, what do we generally do? We do the summation of all the value till 2. So we generally calculate the area till 2. And if this is written in this form, x equals to 2, that means what? You have to just you have to put the value at x equals to 2 with the integrate. You have to integrate for all the values of y and then put the value of x equals to 2. But here in the CDF, you have to calculate, you have to do the summation of x also from 0 to minus infinity to 2. And like if that y x is when the range of x is from 0 to 5, then you have to integrate it from 0 to 2 because till 2 you have to do the summation. That is the one what you can say the problem you were facing, and that is on the discourse also. And in the last session I also mistakenly told you the incorrect code. But okay.
So sir, here for the cumulative distribution marginal, we have to integrate for both x and y, and for the PDF marginal, we have to integrate only based on y.
Yeah, so that why this is because see, CDF you generally write in this form, right?
Yeah.
And for the PDF you'll write this one.
Yes.
Right. So if that is asked for the PDF, like for example, if this asked for the CDF x equals to 2, that means the probability of x less than equals to 2, and we are not fixing any values for y, right? So we have to integrate for all the y. That is one thing, and we have to integrate the x from minus infinity to 2, right? Yeah. But here only you have to calculate the marginal distribution of x equals to 2. That means we are not fixing any value for y. Means we are integrating for all the y. And after integrating for all the y, we have to just put the value of x.
We have to substitute x in that equation, right, sir?
Yeah. Yeah.
Okay. Okay, sir.
So this was the major issue, and
so that means that that graded assignment question, I think it was 11, 12. Those were actually correct, which last time we were thinking is wrong.
Yeah, those were correct. Yeah.
Okay.
Yeah, that's why the answer and all was everything was correct. I only in the last session I got confused with the whether it's a capital Fx and I thought it's a small x. That's why I got confused.
So for in stats 2, we've not come across the CDF marginal actually. We did only marginal PDF.
Okay, yeah. It was only, I guess, PDF. That I was also there. Yeah, it was only that. So okay, fine, but maybe it's a simple only, right?
Yes, sir. Now it is understandable.
Is for small f of x, we don't have to integrate x. We'll integrate only y and put the value of x.
Yeah.
And okay,
okay, so got it. And I don't think so. There is and then the 11th week there was a convolution that we'll be able to solve, and not much is there. Then and there are some concepts related to transform and all, but those is not asked in the exam because those are conceptual question can be asked, but not the conceptual question has been asked in the exam. Like for example, this one, that how generally you transform, that you read in the 12th week also how generally we are transforming if we have been given n normal distribution, and with that n normal distribution you have again a different what you can say the new variable that is in the form of the earlier variable, and how you are doing that with the help of Jacobian and all. So those are conceptual things, but not asked in the exam. And then, and these are simple like exponential. There is some distribution with the expected value and the variance. Those are in the formula also, and not much important for the exam also. But this distribution, like for example, exponential distribution, you can see how, and the Poisson distribution, how generally, like if you have been asked, this is a exponential distribution with some sort of PDF, and then if you have to calculate for what is the probability that x equals greater than its mean time or less than its mean time for the some Poisson distribution for the exponential distribution, you will be able to calculate, right? You can just see the what is the mean time for that exponential distribution or for the Poisson distribution, and then integrate it from zero, like from that mean value to infinity. This is the one thing. And not much in the exponential. I don't think so there will be any issue integrated to uniform distribution or exponential. Or okay, so then we'll move to the next one. If you are having any issue related to this week, you can ask. Otherwise, the problem that can be asked, I already told you, the practice that convolution for sure, and practice some questions from the joint distribution, practice some questions on from the graded, and that practice the exponential or Poisson if any questions are there related to that Poisson or exponential. And then we'll move to the next last. Yeah.
Sir, in the week 11, question number 5, graded assignment.
Graded assignment, question number 5.
Yes, sir. Yes, sir. I was not able to solve this one.
Okay, so what you have to do is, this is a good one, and you can have some sort of questions in the exam also. So what you can do is, you have to just solve this equation. This equation is what? This equation is, what you have to calculate is probability such that x plus, what was that? Yeah, 10 upon x is greater than or equals to 7, right? So what you can do is you can solve this equation. So what is if you are solving this equation, x plus 10 minus 7x greater than or equals to 0, right? And then you will be having the root as x minus 2 and x minus 5, right?
Yes, sir. Yes, sir.
Okay. And then what you can do is, for what values x is greater than 0, you can plot thing. Like for example, this is 2 and this is 5. Just take some values like less than 2, 0. Put it here. If I'm putting 0 here and I'm putting 0 here, so that is satisfying our condition, right? So all these conditions will be there. So all this value less than 2 will be there. If you are putting some values between 2 to 5, like for example, I'm putting 3 here. So this will be positive, this will be negative. So this is not in our condition. Okay, so this we are neglecting. And again, we are putting greater than 5, like for example, 10 I'm putting. 10 I'll put 8 into 5. So this is also positive. So this also I'm getting. So this is our conditions, like these are our the outcomes that we
desired
one. So the what is the final, like minus infinity to 2, union 1, 5 to infinity. But here we have what values? We have that the uniform, I guess this is a uniform between 0 to 10, right? So this is from 0 to 10 only. So that 0 to 10, minus infinity to 2, minus infinity to 2 means the common area is what? The common area is this one. And from 5 to infinity, then the common area is this one. Because for the other cases, this uniform is 0. The common area is this. So from 0 to 2, the probability is what? 0.2, because this is 1 upon 10. So 1 upon 10.
Yes, sir. Yes, sir. Got it.
And so this is how you have been able to solve this.
Okay. 0.2 plus 0.5, 0.7. Okay.
Yeah, correct.
Yes, sir. Thank you, sir. Thank you so much, sir. It was I was not able to solve this question.
Okay. So we'll move to the next one, and then we have not much time. So I'll just go through that. So 12 and for the first lecture, so all the things are conceptual, and how generally you, like this is a portion that we have been discussing, the transform form in the 11th week. These are mostly the those are the help of that thing we are able to solve. Like if I'm having a normal distribution, this much of normal distribution that is written in the form of vector. So how will we represent that? And then again with that, like for example here, that x and x1 and these are not I'm telling important for the exam. I'm just briefly going through that. This we have discussed in the live session also, but I'll just go through that. And these are not important for the exam because these are mostly the conceptual part. Okay, and mostly whatever we have asked in the exam are totally mathematical sort of things. You have to solve each and every problem. If I'm having like 4 questions, you have to solve all the problem, but all are simple. There's no much difficulty in solving the questions. So if you are having like 2 variables and those 2 variables are in the form of some other variables, then how will you do that? Like for example, there was in the last week we have been discussed regarding like if you have been x and y was there, and then that x and we have y and again new variables, and that y and that s, or you can say any other variables were in the form of some other variables. And those variables, how will you do that? If you have to get the joint distribution of the new variable in the term of older variable, whatever been given, then the most important thing is the Jacobian thing. What is that? Jacobian is the covariance matrix that you will get. Okay, so that if you are able to calculate the Jacobian matrix, then you will be able to do that. Like for example, in the end we have and some proper, what you can say, the final result, whatever we are getting. Like for example, if calculate the joint distribution of x, what we have got, the joint distribution f was simply the multiplication of the joint distribution of the x1. That was the one variable, and the other variable was x2. So one gets the normal distribution of x1 and the normal distribution x2 given x1. Okay, that with the help of this graph we have told also. Like for example, this is also in the form of a distribution, the normal distribution, and this is also in the form of the normal distribution. And if you are just fixing one value, like for example, if this is what we are fixing some value x1, I'm fixing, and this also, if you'll see that if this is our x2 equals to rho x2, whenever the line passes this a bunch of data set, you'll see that it's a normal distribution. How you are proving that this is a normal distribution? Because at this point, this is the mean value. At this mean value, you can see that most of the data sets are here. Okay, this is how you can say this is also in the form of a normal distribution. So this was mostly from the first week. It's not important for the exam also because those are all totally conceptual and all. This generally will help you in solving what you can say the expectation, solving that expectation maximization theorem. Okay, the clustering one. And the second part is the estimation of the. This is important. You can just solve some questions if you have been given some distribution, how will you write that likelihood function? The likelihood function, you already know how to write the likelihood function for each of the point. If you are able to write the probability value, that is simply the likelihood. What is the likelihood for getting this value? Okay, so you can write the likelihood value, and for each of the point, how generally you write, you can just multiply it, because all the values that all the data sets you are taking, mostly it will be an independent one, so you can directly multiply that. And after multiplying that, you can take the log and then differentiate to get the estimated value. This is the one way that you have discussed there. That's true. You have read 2, 3 more like Bayesian estimation also and anything also you have read. But here, if I'm giving you the okay, so if I'm asking you to calculate the estimated value, just you can assume that this is the MLE, or related in the question, you have to calculate the maximum likelihood estimated form. Okay, I'll tell you Kaushik, the important one. So the first important thing is the maximum likelihood estimation. So you can expect some questions from the maximum likelihood expected value. Okay, one thing is that. So you should be able to solve this one. You should be able to write the likelihood. You should be able to take the log and differentiate to get the estimated value of that parameter. Okay, that is the one important thing. And the other important thing,
we'll be getting those formula sheets, right? I mean, because for the maximum likelihood, we need all those PDF
so this
functions.
formula you'll be getting. This I told you already. This is the formula sheet you'll be getting. This is the maximum likelihood function. This, right? And for all the other, what you can say, the
the PDFs we'll be getting, right, sir?
The PDF is getting, right?
Yeah.
So this is helpful. Okay. And the other thing that is important from the last week is like, so the third lecture, there's nothing important, but conceptually it is important. Maybe in the further courses and all, you'll be able to know how generally we do the clustering and all. So this is important as a conceptual point of view, but there won't be any question from this lecture. Fourth lecture is important, very important, because there you can expect some questions from the Markovs, or you can say the Trapezium inequality. The inequality will be given in the formula set, but you will be able to solve which Trapezium inequality we have to use if you have been given some conditions. Okay, you should be selective which one to, because you are having 2, 3 equations. Like for the Trapezium also, there are 2 equations.
Could you please share all those 3 as in one go so that we can keep a note of that?
Okay, this is the formula, right? Okay, there it was written. Okay,
here they've given only one, I guess.
Okay, so one you can write. See, if you have been asked to x minus nu greater than k sigma, then you can write less than equals to 1 upon. That is why, because see, if you're plotting this one, so this is the, I guess it's wrong. This is a normal distribution, right? If you have been asked to calculate the area for this area, right? If you have been asked the probability such that x minus this is what? This is simply you can write. What else? This both are important. Yeah. So Trapezium both are important. So if one is the area, this is if one is the area like 1 upon k square, the other area will be what? 1 minus k square. Are you getting my point?
Sir. Yeah. Yes, sir.
Yes, sir.
This is how you can just do that less than equals to, and then you can write greater than equals to 1 minus k square, right?
Okay, sir. Yeah, but so there's one more equation, right? The variance divided by k square, I think.
Yeah, no, Sunita, it was in the stats 2, it was a delta.
Delta, is it? Okay. I remember something like x minus mu greater than or equal to delta.
Because yes, since there is just 1 minute. Since here is a k and sigma, both are there, both are present. So in the actual problem, it is a variance upon the suppose delta is there instead of the k sigma. So variance upon delta square will be there. Whatever will be in this place now, k delta, it will come at that denominator. At the at the top it will be variance. So sigma will cancel and k square will be remain.
Yeah. So this is what you can write this in form also, sigma square upon variance k square. Variance square is what? So variance is what? Sigma square.
Yes, sir. So even on the left hand side, we have only k, right? I mean, there wouldn't be any sigma.
So sigma square will get cancelled, so you'll be having 1 upon k square, right?
Yes, yes, sir. That's what I was saying.
Okay, okay.
So if we have only k out there instead of k sigma, we'll have variance upon k square.
K square, yes.
Yeah.
And that was the problem in the form of delta in the stats too.
Yeah.
Right.
Yeah.
Right.
So you can write in the form of delta also, but you have to use this formula. So if this is the one equation and the other equation, you can write it like directly greater than 1 minus k square, and there the probability will be 1. The probability will be that x will lie between these two values. This is 1 will be 1 mu plus k sigma, and 1 will be mu minus k sigma. Okay, so this is the one other equation. So these are the two important equations. So from 1 you can get 2, right? The second one.
Right.
Yeah. So yeah, so this is important for the
Can
final.
you explain the second equation graphically?
Okay, so this is the one equation. This is the one, right? So if you are having this as some sort of value x, and if you are getting this as a mu plus k sigma, this is mu minus k sigma. This is mu, right? K sigma. So this is the area. So the first equation was this area, right? So the other is this area. Have you got the point? Like this area is what? Yeah. Mu plus k sigma, mu minus k sigma, right? So this area is there, and the other was this area. This.
Yeah.
Yeah. This. So yeah. So one equation is the Markov's and Chebyshev is very important. You can get for sure some questions from the Markov's and Chebyshev, and some questions from that maximum likelihood estimation. So this was important for the last week, and I don't think so there is much thing. There are conceptually that you should read. I'll tell you. Maybe this, again you'll talk in the next course. Whenever you'll go to the theoretical practice, there will be some clustering method. Again, you have to do that. Better to get. Better to be conceptually correct. And the in-term strength will be mostly from. I told you already there will be, I guess, 35 to 40% from the 9th to 12th week. You can expect each week will be having 2 or 3 questions. Okay, if we are having sort of like 20 to 23 questions, we'll expect 8-9 questions from each week. 2 questions you can expect, and some week 3 questions. So you'll expect 2 questions from each week mostly. It can't be like it's not a perfect one, but I'm telling. But and shortly it will be maybe from 10th week it will be 1 question, 11th week 3 questions. So this, like mostly I'm telling you the average value. Each question will be having 2 questions.
Sir, Kkt will not be there, no sir?
Kkt, Ram told, no? It's not there. Yeah.
Okay.
So what are the topics we need to cover for week 9?
Week 9. Please summarize regarding the week.
So, sir, before moving from the week 12, sir, can you please help me to solve graded assignment question number 5?
Okay, I'll do that. For week 9, what you can say, I'll just tell. Ram told you, right? Can somebody say, I was not present at that time, which topic he has told was important? I guess Ram is there or no? No, he's not there. So I was not there. So Ram told anything regarding the important topics. Can somebody share?
Sir said that apart from the Kkt will not be there. Apart from Kkt, question might come from the graded assignment and practice assignment.
Okay, so yeah, that you can, apart from because Kkt generally takes a lot of time, so that's why there's not much from.
We need to prepare a PA and GA for week 9. That's what you mean, Yogesh?
You can practice that 2-3 times and then.
Okay.
Yeah.
Okay. And sir, one last question, like this sheet, right? The formula sheet, like we used to get for states 2, can we get, will we get for the MLF as well?
Yeah, this I told you so many times. Yeah, it will be there. Like in the starting of the questions, all this formula will be there that I shown you just now. This formula set will be there.
Okay.
There's that.
Thank you.
So this formula set will be there. So you'll get this total formula set. All the formulas related to probability, it will be there, right? And there is not much formula related to earlier weeks. Okay, so all this formula will be there. So don't worry about the remember the.
Sir,
Sir, at the
sir,
end of week 11, we have covariance vector. Will there be any question from that? Covariance of random vector at the end of week 11.
Covariance matrix.
No, sir, covariance of random vectors.
It's simple, right? It's very simple, right?
Okay.
So I can't tell you this question will be there or not, but it's pretty simple. You'll be able to solve if there is any questions also, right?
Okay.
So don't worry about that. Like the questions will be pretty simple. Just go through the concept. The covariance, how generally you calculate. If x and y independent, there is no issue with that, right? If x and y is not independent also, there will be some sort of tables and all will be given, right? Or some PDF value will be given. Then only you'll be able to calculate.
So, but last time you said there will be tough questions from week 5 and 6.
Week 5 and 6. Week 5 and 6, not much difficult questions are there, but like what are the concept in week 6? The first concept is what? You should be able to do if you have been given matrices or some function, you'll be able to tell regarding the positive, whether this function is positive, definite, or these are the first concept, right?
Right.
Those are very simple. Like if you have been given any matrices, you'll be able to solve. Not any matrix, those matrices will be mostly symmetrical. Then only the one thing, the matrix should be symmetrical. Then you'll be able. There are 3-4 methods that we have discussed that you can do. Either you calculate the eigenvector, or with the pivot value, or calculate the determinant for each of the like 1 cross 1, go through the 1 cross 1, then 2 cross 2, 3 cross 3, and 4 cross 3, 4. Calculate the simple determinant, and you will be able to say regarding the definiteness of the function. That is the one important concept. The other is what? The other is you should be able, if you have been given some sort of data set. Okay, so the data, what else they can ask? Just go to that. They can ask what? There can be some data set, and related to those data set, they can ask regarding to calculate the covariance matrix. They can ask to calculate the transform data set, right? So this can be the question. So if you are able to practice that graded assignment and practice the question, so you'll be able to solve for sure. That is what I told you. Because this time this is a pretty simple one, because we have not even asked to calculate the transform point also. And those data set was also simple, right? So you can get some sort of data set, but conceptually should be very sounded so that you can able to solve that.
Right. Okay.
Anything else like?
Sir, please tell the important topics for week 11, sir.
Okay, so week 11, I told you the convolution theorem you should be able to solve if you have been given. One other thing is the joint distribution. The joint distribution you should be able to calculate. Just the formula, basic formula. If you have been asked regarding the, you should be able to have the difference between the what is when you calculate the cumulative marginal distribution, when you calculate the what you can say the simple marginal distribution. Okay, this is the one thing, and the conditional thing. So you should one thing I'll tell you. Practice some question related to convolution, and practice some question if you don't have much time, because we are having only one today. Practice some question on joint distribution and conditional distribution. Okay, like it's a pretty 10th and 11th same. So practice convolution from 11. Practice some questions on joint distribution, and for the 10th week also practice some question on Bayes theorem and joint distribution. We'll be able to solve that. I'm pretty sure related to 10th and 11th week. Okay.
Okay, sir, thank you. And sir, for 1 to 4 and
1 to 4, I'll tell you. See, 1 to 4 each week will be having 1 or 2 questions. Okay, maximum 2, minimum 1. Okay, and from the first week, just go through how to calculate the losses. Okay, just be able to calculate the loss for each of the things. Like if you have been asked to calculate the loss for some basic what you can say linear regression, or like what was the loss function has been taught in the first, whether it's what you can say the dimensional reduction, or any of the three losses function, I guess, has been taught in that. So you should be able to calculate the loss value. From the second is just practice the previous from questions and all. The second week is also pretty simple. the differentiability and continuous, those things are there, right? In the second week. So just practice the last term question, and from the third, fourth week, you can expect some question from eigenvalues and all, because those are important. So, and what you can say, the important properties of that, how to diagonalize and all. So those are important from fourth week. So each week, one question you can expect maximum.
Thank you, sir. Thank you, sir.
Yeah, only loss function is important for first week. There's not much in first week. What can be asked? So if we are asking the mathematical, only loss function can be asked. Just practice that loss function from first week. Okay, so I guess it's done. So we have told you almost, so whatever the time you're having one to this, whatever I've told you, if you have practiced other thing, you are good and fine, like fine. And if you are not practice much, if you're not having that much time, you'll practice this sort of bunch of topics that I've told you, and you're ready to go and can write the exam nicely. Eigenvalues are important. Eigenvalues is always important. If you have been given some matrices, or if you have been given some characteristic equation, to be able to calculate the eigenvalues. Yeah, that is important for. So yeah. Other than that, I guess good luck for the exam. Like
week 12, question number 5, graded assignment.
Okay, I'll go.
Please, sir.
So the SVD and PCA, I've told you what can be asked. Practice graded and that practice assignment. For SPD, just go through the the proper the properties, how when generally it's unitary method, if you have been asked reality whether this is unitary or Hermitian and all. So those sort of things, the properties, you should be aware of that from the SPD chapter. The 5th week is, I guess, yeah. And so we have to solve the 12th week, right? So 12th week, which question?
Question number 5.
Okay. So
yes, sir, this one.
Asked what you have to do. You have to calculate. Okay. So D has been given, right?
Yes, sir.
Y is also been given in the starting. Okay. So what's the issue in that? You can calculate the everything for Z1. How generally you calculate the mean of Z1? The solution isn't provided, right? What's the issue in that?
No, sir. Solution in the solution I had seen the no calculation has been given. Only it has been given that the Z is equal to variance of CY.
Okay. So here, see, in spite of C, you are having D here. And see, for example, you have to calculate everything for the Z1.
Yes, right? Sir.
So just take the first matrix, or you can for D, yeah.
And if and 2, 3 previous values I have to use from the previous one.
Yeah.
Okay, sir. Okay, sir. Got it, sir. I was not using the value of. Sir, can you scroll up? No, scroll up. Means the values for which I have to. Yes. Okay. Means mu I have to use 2, 3, 4, and then 1, 1, 1 and 3, 1, 4 transpose I have to calculate.
Yeah, you can do that like that. And then also you are not like if you are not able to calculate this, push to the Discord site. Somebody will solve for you.
Okay.
You can ask you also. You can ask in the mail I've given you, right? You can.
Okay, sir. Okay, sir. I will send the mail. Okay, thank you, sir.
Yeah. So anybody, if you are having any issue, you can mail me directly, because you are having 1 day's more. You can mail me if you are facing any issues related to anything. So we'll try to discuss that. Okay. And yeah, so we're done, I guess. So most of the important things I've told you already. I don't think so there will be any issue. I've seen the papers are pretty, not simple as quiz 2, but it's a moderate one, not difficult one. So you'll be able to do that. Okay. So all the best for your exam, I guess.
Thank you, sir.
Thank you, sir. Your sessions have been one of the most helpful ones throughout MLF. Thank you.
Thank you, sir.
And we all do not know when we will meet again or not.
I will meet, yeah.
Because this is last session.
Okay, I'll be taking the session in MLP also.
Okay, sir. Okay, sir. Thank you.
We'll meet mostly. Yeah. So, are you guys are coming? I guess you have to come, right? You have already you took the certificate for that foundation.
Yes, sir. Yes.
Yes, sir.
You already took. Okay. So when with the guys who are coming in May, I guess IIT. Some people are coming, right?
Yes, sir. We all will come.
Okay, May you are
20th,
coming. We'll meet there. Okay.
Yes, sir. May 28th, 20th, 21st, 22nd.
21st or 22nd, right?
3 days.
One question, sir. The foundational level certificate is given physically?
Can you repeat that? Like your voice was having some glitch.
Sir, means the foundational level certificate is given physically from. I was just asking that.
It was given in
No.
physical form. Okay, not.
Only digital form they have uploaded in the dashboard.
Yeah. I saw that.
Yes.
But you can, I guess, but there is some sort of time you can come and meet us, right?
Yes.
So I'll just share my mail ID also here. Degree.it.ac. So this I've shared in the mail also. And mock we are not releasing, so sorry for that. You can practice the last term question itself. Okay. So I'll just stop this sharing.
Yes, thank you, sir.
Yeah, thank you.
One doubt, sir.
Yeah.
Will the question paper pattern be same as the last term?
Pattern means what? Like, can you specify?
Like the weekly distribution, like week-wise distribution.
I'm telling you, like, I have not seen. I'm not seen. Honestly, telling you the final term, I've not seen. This term I've seen you, and that's how the weightage I've told you. From first to fourth week, there will be one maximum 2 questions. And similarly, there will be 4 questions from the what you can say for first 4 weeks, and then there will be some sort of from 5-6 you can expect a bit more questions. So you can expect from 5 to 8, 30% of the problem, and then 40% of the problem from the last, like 8 or 9 problem from the last 4 weeks, and then 8 from the first, like 8 questions from the last 4 weeks, 4 from the first 4 weeks, and then 7, 8 questions from the 5 to 8 also. So this will be the distribution. I got you.
Okay.
Got it, right?
Yeah, got it, sir. Thank you.
Okay. So yeah. Oh, okay. Then I'll leave that. I've given you the mail ID also. If you are facing any issue, you can mail me. Like till tomorrow, you have time. And all the best, everyone. I hope you will be. We'll meet in the MLP again. Thank you. Thank you for the session.
Thank you, sir.
Thank you.
Thank you so much, sir.
Thank you, sir. Thank you.
Okay. Thank you, everyone.
Sir. Sir. Excuse me, sir. Hello.